Okay, let's start. Can you hear me okay?
I hear you.
Okay, so let's continue on our UML models. So here I give you the revisit the schedule. So this is where we are this week. And then you can see that so by the day we're going to finish the UML. And starting from next week, we discuss unit testing and the Docker. So yeah, I didn't put it in the schedule here, but next week we're going to discuss that. A week after is the 10 project oral, and I will get you the 10 project. Yeah, since you are already finished lab 6, 7, and 8, and then continue working on 6, 7, and 8, and then eventually the outcome, I mean, the product will become your 10 project. And your TA is going to give you the schedule to do the presentation. Basically, you're going to do the presentation on Zoom. So you don't have to meet her in person. If you prefer meet her in person, she can also arrange that. Okay, so let's move on to the UML. So this is the So today we're going to focus on the sequence diagrams. So last week we discussed class diagram, we can discuss a state diagram and activity diagram and so on. So this week we focus on the sequence diagram. This one is a representation of behavior as a series of sequential steps over time. So the purpose of using a sequence diagram is to describe the interaction between the object. So we know the class diagram shows the structure of the design, and as for how how this object interact with each other, how this message send back and forth, and how this like a function code and what's the return value and so on. So all these things can be described by using the sequence diagrams. So this one is a form of interaction, shows the object and shows how they communicate. Okay, so these are the elements involved in the sequence diagrams, and like the actor and the boundary control entity. These three are three different kind of object. So in general, this sequence diagram is about interaction between the object, but we further classify the object into three refined object we call the boundary, control, and entity. And in the next slides, I will show you the differences of these three objects. And then the lifeline is basically if you do not classify the object in any of these three categories, we call them the lifeline. So basically, this is a general object. You don't want to classify them further. And then the messages is the functions. So all these objects, they come with operations. So basically, the message is a function call. And so here, the self message, you can see that message is a function call, and the self message is the object call itself. Yeah, so this, I mean, that can also be realized in the program. I mean, an object call operation that belong to itself. That's very common. And it's a lost and a found message. So basically, when this function call or the message has no specific receiver, what you cannot tell who sent the message from, then this message considered lost and found. It's not actually lost. It's just you do not know who actually received the message. A lot of times when we design the software, we try to decouple the sender and the receiver. We try to decouple. I mean, we using decouple the design. In that case, a lot of times we try to make the message sender and the message receiver kind of independent, so that when you make change to the sender, it won't affect receiver and vice versa. So in that case, a lot of message you do not have a specific sender or receiver. So in here, we can use the loss and found message to model that scenario. And of course, a lifetime, a lifeline is an object, is a general object. You can create an object, and then you can remove an object, and this can be reflected in the sequence diagram. And duration and time constraint. So this one is a very important when we model the object in a network environment. A lot of times when you send a message and you may not receive the return immediately, or the message itself takes some time to reach the receiver, especially in the network environment. This can take time. So here we can use sequence diagram to model, then you can give some constraint. So which means I send a message and I expect this message reach the receiver in less than like a 20 millisecond and so on. And a gate is when you have a object quite complicated, and then you can cluster some, you can group some function into the gate, then you can have a multiple gate. So this is only when an object become very complicated, contain a lot of operations, and then you can group them into different gate. So these are the elements involved in the sequence diagram. So this is a very typical sequence diagram. Usually a typical sequence diagram we consider as non-trivial should involve at least a boundary, which is interface, and a control object and an entity object, which is the boundary is like the interface. So user need some interface to act on. Even if it is function, even if it is API call, still that API serves as a boundary, serves as an interface. So we need an interface, either interact with user or interact with other systems through the API call. So we need an interface, and then all the operation in the sequence diagram eventually is going to operate with some data. So data we call the entity object. So whatever we are doing here involves some data. So here we have a data object, or what we call the entity object, and then between the interface and the data, we have a control object. Control object is used to coordinate between the interface and the data. So when you draw the sequence diagram, the first thing I check is to see whether or not you have all three kind of object. When you have all three of them, I consider this sequence diagram is significant enough. Otherwise, you can just have a very simple one, but that that one doesn't count, right? Because we use this sequence diagram to illustrate some complicated operation. If the operation is quite trivial, then we don't need to commit such a great effort to draw a sequence diagram to do that. It doesn't make sense. So when you draw the sequence diagram, you need to have at least boundary, control, and object. And please incorporate all three of them in your lab and in your term project. So from here, you can see that this one is a try to create a contact, and the contact will be saved into this database, this contact entity. So you can see that in order to create an object, we need to have a kind of interface showing that allow you to enter the information, something like that. So suppose this is you view the contact list, and you find out your contact is not in the list, and then you click on create a new. So this one will pump up another. So this one will be contacted with contact manager. So this one is a control object. So this object will pump up a new window for you to enter the information about the contact. So when you enter all the information in this interface, you click on the save button. So basically now you send the message. So here is when you click on save. So the save message being received, and then this interface will contact this contact manager, is a control object again. So this one will see that, okay, I got all the information and you want me to save, and then I call another control object that used to connect with the data. So that one we call the data management, or like the persistent manager. So this one will actually connect with the database and then insert the content into the data. So you can see that for simple create a contact, we need to have these three kind of object. And you may wonder, like when you click on save, why don't this interface just directly write to the data? So you could do that for small project. You can do that. Just integrate everything in one object. So this one display the interface and then also connect with the database and manage the data connection. Do all the things this control object doing. But if you choose that design is not. If later on you may choose the old design course, you will see that that's not a good practice. So we try not to integrate everything into one object. It's better to separate them into different things. And also, especially when you connect with the database, it's better not to allow like the interface object, which is communicated with user directly, gain control over the data directly. That's very, very dangerous. So whenever you have a data, it's better to let another object that specifically handle the data to control the connection, to write to data, to update to the data, and to delete the data. All this operation should be done by independent object that's dedicated to these operations. So then then in between you have another object to coordinate. So basically now we have a design like interact with data with user owning. We have an object interacted with data owning. Then we have an object to coordinate in between. So again, that's we separate the responsibility into different objects, and then this will make the maintenance much easier. And your design is also quite straightforward. Is clear. So the design is not how to do a better design is not the focus of this course, but please keep in mind that in the future when you're working on the OO design and the system design, you will see that we separate the responsibility and into different module. And so that's we call it, especially like one module just do one thing. One module just do one thing. So that's what we call the increase of the cohesion. Instead of put everything in one object, that will be a nightmare in the maintenance. Okay, so this is example, and this is another example, like to manage the shopping cart. There's a few things not exist in the example one. Is the one thing is the new. So this one is just it's like a create a new object. So we can model that in here. So the new is like when you create when you call a constructor of an object like a new. So this one is corresponding in your program. So this is a message is create a new object, and this one is called the self message. Remember in the previous slides, I showed you that you can call a function that belongs to another object. You can also call a function that belongs to yourself. So this one is a self message. And this one, you can see that is different from others. This one is a return message. So which means when you make a function call, but you don't get return immediately, you're going to take some time for you to get the return. So here is to model the asynchronous system. So a lot of times the function call is not synchronous, which means you do not get the return immediately. It's going to take time. Yeah, for example, like when you send an email, when you send an email to a list, and then you're going to send one by one, right? You're going to read the first email from the email list, and then send the email, and then you read the second email from the list, and then send to the second one, and then you have for loop sent to everyone in the list. So that's the program to do that. But in order to implement that, there's two ways to do that. One is when you send the email to the first one, then you wait you wait there to make sure the first email sent either successfully or not successfully, well, whatever you need to wait there to get the result. Then you go to the second one. So that's one way to do that. So that is asynchronous. So I have to wait for the response before I commit to the second one. So that's synchronous. But a lot of times the program is not synchronous. Is I send the first email and then I immediately send the second email and the third email. I don't wait for the first one to complete, so that I can speed up. So that in that way I can be very fast. And then first email, then how do you know the first email being sent successfully or not? Then later on, like this asynchronous, I get a result later on, but I don't wait. Yeah, I immediately to the second test and the third test. So that's called asynchronous. And then that can be modeled using the sequence diagram by model this return message. Yeah, return message. You can see this return message is not immediately coming back. It takes some time to come back. Okay, so in here, in the previous two example, I already show you that we have a three object type, entity object is to represent data, and the boundary, the object, you can consider that one as an interface. It's either interface with a user, with a human, or the interface with other object. So this boundary object, control object. So represent control. That's to coordinate between the entity and the boundary. Okay, so these are three of them. So in this particular example, I show you like in the previous, in the last week's lecture, we have this two-button watch object. We know there's a year, month, and a date, and we have a change date function. And a change date object, we have a button, we have LCD object. So this object, the first one, the year, month, and date, these are the entity object because this one, handles data specifically. And the change date is the control object in this button, and the display, the interface, or we call the boundary object. Okay, let's see the message. So usually the message is a message is a function call, and also the message can be the synchronous, can be asynchronous. When you have a return message, it's called a synchronous message. Nowadays, asynchronous message become more and more popular, especially when you try to handle a lot of requests. You do not want to wait. There's one request to complete, then I do the second request. That will slow down your process. So the asynchronous message, asynchronous design become very popular. Okay, so this shows you that you can send a message and then you can wait for the return. So this is a very typical asynchronous design. And the self message, I already show you in the second example. You can call yourself. That's also very popular. A message can be lost and it can be found, which means you do not have a specific sender or receiver. Nowadays, especially when we have this decoupled design, we intentionally decouple the sender and the receiver. So this also become very popular. And the start lifeline, start or end. So the new is like when you call a new, when you call a constructor of an object, then you create a new object, and also you can delete an object to remove it from the memory. Okay, so by default, a function call takes no time to be received. So the function call may take some time to run, but the function call itself takes no time to arrive. However, in the network environment, the function call can also, for example, like an API call, you call API in another domain, and then this message travel take time, and the message travel, and you need to authenticate the message, and this also take time before when you send the message, by the message actually being processed, it's going to take time. So here we can model, you can give a constraint that, okay, I want my function call being start to process in less than, I mean, may take more than 10 milliseconds for them to practice. So this one, give you some idea how long it can take, and also you can say that it's less than. Well, that can be a constraint. Yeah, can be your requirement. Yeah, I know it's going to take time, but it cannot take more than 10 milliseconds to arrive. So something like that. Okay, so here we can model the time constraints for the function call for the message. Okay, so in here, like we can for complicated object, with a lot of operations, then we can group the operations and put it into a different port. So there's a port one and a port two. So port one consists of like a group of operation, and port two is a group of operations. Then you can just send to different group, and of course between the group, you can send a message as well. So by incorporate this we call a port, we can like make the function call very, I mean, easy to increase the readability. If if instead of using a port and you have individual message, then you will see that become very complicated. Yeah. Okay. Let's use our lab and the temperature example. I show you this one last week. This one is the use case to create a new expense. And then last week I show you that based on this flow of event and how I come up with these class diagrams. So now we are going to go one further step. One further step. Once I have this class diagram in the statical form showing the structure, how this operation actually does. If I really want to create a new expense, and how this object coordinate interact with each other to create a new expense. So okay, so this is the sequence diagram, and I will show you how I draw this sequence diagram. Okay, let me move this one away, and okay, let's come here. So this is enterprise architect. Suppose you already have the class diagram, and you click on this class diagram, already show you that these are classes I have. Then let me see this. Let me close this one. Let me start it from new. How I get. Let me start with okay. Suppose you have class diagram, and then I want to create a sequence. Then you can add the view, and this view is not class diagram. You can say this one is a dynamic, and then you can say this one is a sequence diagrams. Yeah, something like that. Okay, you have sequence diagram. Of course, in here you don't have anything here, and then you right click on it, and then you can add. Where is it? Okay, you can click on add diagram. Add diagram. Then you can choose behavior. Choose category of behavior. Then you can see that there's a number of diagram you can choose from. In here we choose sequence diagram. And then you click on here. Oh, of course, you need to give a name. It's better. Okay, it's not called a sequence diagram. You can call this one like this one is add expense. Add expense. Okay, so now I have a add expense empty diagrams. So so here first is a user, right? Yeah, it's a user. So what the user does, uh, okay, yeah, you can have just give a user, okay. You click on okay. So basically, this user is going to interact first with the user view, try to log in, and then once logged in successfully, then this user view is going to pump up a new view. Then the new view must contain like a create expense button. Then you click on that button, and then that button, and then that will update this user view and show you the interface how to enter the expense information, like the amount, like the date description, and who's involved, and so on. And then you click on add, and then this expense being added. So basically, that's the operation. So you can see that the user need to interact with the user interface. We call the user view. So in here, you can just drag in here. I want to connect with, and I want to connect with a boundary. Of course, this user view is a boundary, right? In here, you do not need to give a name. Like by default, it's called the object one. You don't have to. However, you need to commute. You need to associate this one with a class. This one is just a general boundary object. Then you need to associate this one with a specific class. So what you can do there is to right-click on it. You go to the advanced, you go to the instance class field, or you can just use a shortcut, Control L. Okay, so this one will pump up a new window, and then you need to choose. Here you can go to class diagram, class model, then you choose a class. So this class is a user view. So from here, you can see that in order to draw the sequence diagram, you need to have a class diagram already. And the class diagram must be in a detailed design model, must be in detailed design, including the name, attribute, and operation. Then you can draw this. Okay, then you need to specify the message. So when the user get a the user view, you can see the first view is net you to log in. So this should be like the first page is the login page. Here is a login page. So in this login, you can imagine that the user enter the username and the password, and then click on the login. So here is a user is doing something. So once the user enter the login, then this is going to authenticate. It's going to check. It's going to check if the login is legit or not. So here it's going to call. Call the control object. So this control object. So from here we know that. So here the control object is the DAO manager. So DAO manager is going to connect with the user. So here, so this DAO manager is going to manage the connection and manage, authenticate, get username and the password from the user view, and then check against with the user table to see if the username and the password is a match. So you can see that this one is Control L. Control L. This one is the DAO manager. So DAO manager. So this and this message. So this message is authenticate. Yeah, this message is authenticate. So when you authenticate, it's going to take some time because first the DAO is going to make connection, and then run a query to check the username and the password. So once it's checked, if matched, and then this one should have a return message. Yeah, it should have a return message. So this one is actually asynchronous. This one is not immediately. So you can see that it's going to take some time. So here you can see this one is a return. So how can model is a return? You click on here is a return message, and then you have the return value. What's the value of the return? So from here, let's go to our authenticate. So in here you can see that our authenticate is to return an integer. So you can see that probably here the integer 1 means successfully, and 0, if return 0 is denied. Yeah, suppose if that's your design, then I can say that okay, the return value is successful, it's not valid, it's a 1, or you can say and it's 1 means authenticated. Yeah, authenticated. One means authenticated. So now I know that, okay, this one, if it's successfully, okay, so once the user view saying that it is a legit user, the next is, then it's going to pump up the main window. Yeah, I mean the main view. So here it's going to, this one is like, it's going to send itself a message. How to do that? You can just, hold on, you can just click on this arrow and then you turn around to the self. So this one will make a self message. And this self message, if you click on the self message, okay. Hold on, let me see this one. Okay. The self message is to display panel. So display panel is to show the main page. And then imagine that in this main page must contain uh a button called create expense. So when you create expense, then when you create when you click on the create expense button, what it does is going to eventually it's going to create, yeah, it's going to create this uh so this object, yeah, this object. So how I can do that? So you can see that let me see, expense. Oh, I'm sorry. You're going to create this object, create this expense object. So this object is going to collect amount, date, the description, and the group, and so on. So here you're going to create this object, and then so here this one is going to create. You can see this one. I'm create a lifeline, but create a lifeline, and this lifeline is associated with the expense, a class expense, not table expense. It's class expense, class expense. And this one is being created. So which means this message is to the life cycle. You can see that this life cycle is a new. So which means this one is to create object. Okay, now you will make new. So you can see that this message is to create this expense object. Okay, so now in here you're trying to enter all the information, and then this information is handled by this expense expense object. So you can see that this expense actually handle two things. One is to like the expense itself, and then the expense is to handle the group. Yeah, who is involved? So here is like two things involved. One is the expense itself, and the other is the group. So this implies that this expense is going to first show that who is involved. Who is involved? So which group involved in this expense? So here the message is like the manage group. Manage group. So in order to manage the group, so this one, this DAO manager is going to check the user group, and this one is entity. So click on that. So this entity is Control L, check group information. So this is a user group. Yeah, user group. So what it does is to make sure, so this message is for This one is going to check, yeah, check group members, check group members. So you know that this one is to check group members, who's involved. And then once the expense information being filled out, the next, when you click on save, you're going to update the event. I mean, update the balance. So, but the expense, this object is not responsible. This one is not responsible to update. So because this updating activity take a lot of like effort. So it's better to let another object to adjust the balance. So that's why we have another object is to balance adjustment. And this one is to use, I mean, this one has only one function to update the amount. So you may think that why don't I put this update amount in the expense here? I do. So well, theoretically you can do that, but if you do that, you can see that this expense do two different things. One is to manage the expense and also is responsible to update the amount to manage the group, how this individual update the amount. So there's too many things you put in one object. So you know that when we design the software, we try to minimize the coupling and maximize the cohesion. So if I put two unrelated operation in one object, that's it decrease the cohesion. So which means your one object have to handle too many unrelated operation. That's not a good design. So it's better if you like this update amount and this just handle expense. They are two different things. So it's better to put into two object. So once come to the update amount, we net another object to handle that. So that object is balance adjustment. Of course, that one is a control. Click on OK. Control L. This one is the balance adjustment. Balance adjustment. So this one is to update the amount. Update the amount. Of course, once you update the amount, the next so eventually the data, when you update the amount, eventually the data, the expense data and who's involved and what group involved, eventually it's going to write to the database. So in order to write to the database, this balance adjustment need to ask the DAO manager to do that. It's better not let this balance adjustment, let this object communicate with the data directly. And anything when you need to do, to communicate with data, it's better to throw this data manager. We call it DAO manager. Okay, so here we have the update amount. We know who is involved. The next is to manage the expense. So here, this one is the balance. Send back a message, and this message is to manage expense. Manage expense. Okay, and this manage expense is actually write the expense into the expense and expense and user. Yeah, and then who is involved. So here you're going to incorporate with two data entity. Yeah, data entity. The entity. One is expense, or not expense, is the expense table. Expense table. And the secondary is to update expense user. So it's better you tell like what you update here. So here is to add expense data. And this one is to update user amount. So yeah, so you can see that these two are separate because the user may associate with multiple expense. So here you need to update. So and this update information is from this balance adjustment. This balance adjustment reconcile every user's balance, and then you just update in here. So here is you can see that you add a new expense on the surface. Looks very straightforward. I just add expense, and here we can come up with a class diagram. The classes get involved, and then here we can see that how this object communicate with each other. So you can see that drawing a sequence diagram is not a trivial work. So I want you to so in your lab 8, I want you just to draw one sequence diagram. So in order to do that, the first thing you need to have your class diagram ready, or at least the classes involved in the sequence diagram must contain all the information, so that you can draw the sequence diagram. So the reason when I click on each message, and this one allow me to choose the message is because this message is the operation that belong to this DAO. Yeah, so you can see that this message sent to the DAO manager. So this function call is the operation that belong to the DAO manager. So your DAO manager must already have this operation in order for this message allow you to make choice, because this one is associated with the operation of this class DAO manager, these operations. So you need to have a class diagram ready in the detailed design model, in the detailed design level. Then you can draw the sequence diagram. So you can see that my first task is for you to refine your class diagram in Lab 7, and the class diagram, so make them in detail level. And of course, your class must contain the boundary, control, and entity classes. So in here, you can see that in my place, this user view is a boundary. And the expense, the balance adjustment, DAO, all three are control. And then this table obvious are the entity. So in my example, I already finished the first one, refine the class diagram, and then draw one sequence diagram, and to draw one sequence diagram, and this sequence diagram must contain the boundary, control, and entity object. Yeah. Okay, so the user interface diagram for user GUI prototype. This one is like you can just here you can add a new view, and then you can have this. Now from U view, you can for example the login, the UI. Then you can have a login. So in here, then you can draw. So you can draw a screen here. And say this one is a login, for example. Login. Yeah, make this one is bigger. And then you can have a text. This one is a user name. Yeah, username, and then you can put a label here. And put a label here. Yeah. Username, something like that. So this, I know that this one is and then you can put a password and so on. So here, and then you can have a button here. This one is called submit button. Yeah. So this is, you can you can design an interface, and then for here, then you can design, when you log in, then you have a new page. It's a home page showing all the different information. Of course, they want to have a one create expense button. So in here, you can have a very simple one. So this one just give you you can practice like how I can mock up the system. Okay, so this is lab 8. Then let's look at the term project. Okay. So the term project, the user description, the user requirement still here, the same as your lab 6, 7, and 8. And then your UML model is more than what you have in the lab 6, 7, 8. In your lab 6, I ask you only draw one the 3 use cases and the content detail of 1. And then in your term project, I want you to have into 20 use cases and the class diagram. And the class diagram, I already show you that from one use case, I got the class diagram. And then you need to have so it's all start with the use cases. All start with use cases. Let me show you something here. Hello? Okay. Okay, suppose that you have so this one illustrates like how this use case and the system, the requirement connected. So suppose that you have the first level is the user requirement. So this one is more like what we have in here. So you can see that each one here is a user requirement. So you can give it a label like this one is 1, this one is 2, and this one is 3, and so on. So the system requirement is to put more detail in here. Of course, you cannot just rely on the user requirement to develop software. You need to put a detail in here. Suppose like the first requirement, I break down into 11 system requirement. And in this 11 system requirement, the first one, do I need a further clarification? I say, okay, this one is very clear. There's no need to further clarification. The first 3, there's no need. And the fourth one, I think I need a further clarification. So in here, I draw a use case to further illustrate this system requirement. So here the use case I draw is called add expense. And then the next 2 system requirement is very clear. There's no need to further clarification. And 1.7, and I feel like I need to further, like this calculated balance is going to involve like a reconcile different user. It's kind of complicated, and I need further clarification how to do that. So here you draw a use case to illustrate how to calculate the balance. And then for the rest of them, I don't need to further clarification. So from here, you can see that you may have like 10 system requirement, but end up only two use case. And then for the second user requirement, you break down into 16 system requirement and identify 2 of them. I need to further clarify so that I draw the use case to further illustration. So here you can see that in our term project, I want you to end up with 15 to 20 use cases. So you may have like 100 system requirement, but only 10 to 15 system requirement you identify that need further clarification to draw the use cases. So here eventually you have a 15 to 20 use cases. Of course, each use case here contain the flow of event. Remember, in the use case, the most important thing is the flow of event. And then based on the flow of event and what we discussed last week, you can draw the class diagram. So this is based on one use case. And then from the second use case, you can draw, you may add new classes into this existing classes, and then you may refine this existing class diagram. So you can see that you can choose just one use case as a starting point, and then the more use case you have, the more classes you can add into the existing class diagrams. And for the individual class, you may add more information into it as well as you get involved into more use cases. And since this use case is associated with system requirement, I'm sometimes from system requirement itself, system requirement itself, the description, you can also come up with some classes by using the same the word analysis. You can further refine your class diagram, and then if eventually you have so many classes, it is not easy to show all the classes in one class diagram. Then you can group some of them. Okay, say, okay, I can just make this four. I can make this, I can move this four to one class diagram. I can create another class diagram and then group the rest of them into another class diagram. So as for how many diagram you have, that's totally dependent on you. It's how you want to group them. Yeah. So basically, you usually make a change to the class diagram. You just to regroup them into different diagrams. If you believe that one diagram can accommodate all the classes, that's also fine. That's also fine with me. Okay. So that's the term project. You need to have start with use cases. Of course, I'm sorry, start with the system requirement. And then from the system requirement, you identify the system requirement that need to further clarification to draw the use cases. And each use case must contain the flow of event. That's what we call the further clarification. Yeah, further clarification by adding flow of event into the use case so that I know what this one actually does. Okay, so then you draw the class diagram, continuously refine your class diagram, and then eventually you only draw two non-trivial use case scenario for the sequence diagram. So remember that I only ask you to draw two sequence diagrams. So in here, I already show you how I draw one. So you can see that drawing one sequence diagram is not trivial. So I only ask you to draw two, And the state diagram, you need to draw three state diagram. Please keep in mind that state diagram is associated with one class, So three state diagram associated with three classes. So I showed you last week how to do that. So please refer to the video. So here you need to have a state diagram and activity diagram. Activity diagram is to apply the swim name in here to separate the operation. Okay, so your temp project, you put everything into a zip file, and this zip file first contains this enterprise EAP file. So here, if you save this one, you will get an EAP file. So this EAP file is included into this zip file. And here I want you to have a PDF document. So this PDF document contain the functional and the non-functional requirement in system requirement level. So here, remember in lab 6, you practice from user requirement to system requirement. And so here you need to have a break down each user requirement in system requirement, and in the system requirement, and some of them is functional and some is non-functional. And I show you in the lab 6, I have the requirement example. I show you how to break it down into functional and non-functional. So it is better when you have the functional and non-functional and put them into this hierarchy. The user requirement 1 is associated with the first user requirement in the document, and then you further break it down into the 1.1, 1.2, and so on. and then show me that which system requirement you choose to further clarify by adding the use case. Yeah. Okay, so here in this document, in this document, you list basically something like what I show you in this Excel. Then of course in here, you can copy and paste the UML, the UML diagrams in here, put it into this document. You just copy paste here and give some explanation. You don't have to copy paste everything. If you can copy just something, some is very obvious. You don't have to do the explanation. If yeah, for example, like here, if you can tell me like this sequence diagram is used to describe this use case, that'd be great. Yeah, so you can put that in the PDF. Give me some description. So in here, please also provide your PowerPoint slides because you're going to present. In here, in your PowerPoint slides, you only show the class diagram, sequence, state diagram. Only put this in the slides. The reason I want to put this in the slides is you're going to present to the TA. You're going to show her that how you come up with the class diagram. And then the sequence diagram, how the sequence diagram is connected with class, and which state you are talking about, and which class is related to the state diagram you are talking about. So you need to explain that. Please put it in the PowerPoint slides and do the presentation to the TA. I think I believe last week I also yeah, the term project I already posted. And here I already post this term project criteria. So you can use this one to check against your term project. First, do not be late, and please have a complete diagrams. So if there's an incomplete diagram, you're going to take 10 points. For example, ask for 15 to 20 use cases. If you only provide like 5 use cases, then you're going to deduct 10 points. If, for example, I ask for 2 sequence diagram, if you only provide 1, you get 10 point deducted. So each use case must contain flow of event. So this is the key. Please keep in mind that the use case is used to further clarify the system requirement. If we don't put the flow of event, then what's the point of having this use case? Yeah, so this flow of event is the key for the use case. So each use case must contain flow of event. If not, you're going to have a deduct 5 point. And each sequence diagram must contain boundary, control, and entity object. And this is to be considered as a significant, non-trivial. So if not meet this requirement, 10 point. And the sequence diagram message must synchronize with class diagrams method. And I showed you last week. So if it is unsynchronized, 5 point. And swing name must be applied to the activity diagram to separately regroup the activity so that different users responsible for different group of activities. So swing name must be applied, 5 point if not. And the state diagram trigger event must synchronize with the diagram's method. And the functional, non-functional in report. So you cannot just have you cannot just have a system requirement. You must further clarify them into the functional and non-functional. Yeah, so this is a very important part. Your report must contain this requirement. And if you list them in wrong category, for example, you put the functional into as a non-functional or non-functional as a functional, this one cost you 5 points. It's not big deal. And then when you do the presentation, keep in mind that your presentation is about 15 to 20 minutes, and you must you must be able to explain the logic between the use case flow of event and the class diagram. So that's what I show you last week. I explained that when I have this flow of event and how I come up with these classes. So you must be able to explain the logic. So the TA will not question about your logic. Well, the TA won't say, okay, your logic doesn't make any sense. TA won't say that. But at least as long as you can explain, okay, that's my way of thinking. Even it's not perfect, but that's not, but that's my that's my logic. So as long as you can explain the logic, you're good. And also for the state diagram, in a state diagram, you must be able to connect the state with the attribute. So like you can say, okay, this state associated with what attribute. So this one is a key. When you explain the state diagram, the state, and the TA may ask you, okay, what is state and what is state associated with what attribute? Can you explain? You must be able to explain that. And for the sequence diagram, must match with in the classes to explain what scenario described by the sequence diagrams. And also, also the sequence that all the message, is associated with the message listed here. For some of them, for example, like this data entity, because this one is a table. So table doesn't contain any operations. So the table is just contain pure data. And in that case, you can make up some message. You can say that this message is updated user requirement. Then we know that this one is related to update query, the SQL statement. Yeah, you know that. If you learn the database course, you know that this update. The update query. So since this one is a table, you cannot just specify what table does. We need to have some external query, SQL query to do that. So I consider this one is an update. Yeah. Okay. So I think that's it for today. Any question regarding term project presentation and your lab?
Okay. So I have a bunch of questions. So my first question is, we're only using PDF for the report file, or is Word also allowed?
Yeah, Word is also allowed. Yeah.
Okay. All right. So let me see. Okay. So let me see. For the report itself, should it also have all 5 types of the diagrams in it as well, like each one pasted in there?
No, you don't have to. So since you have so many diagrams, for example, like use cases, you have a 10 to 15, you don't have to, paste everything in there. So so some of them, well, is your own judgment. You just paste a few that you believe, like you need some explanation. Otherwise, you don't. Because all the information you have, the diagrams you already included in here, right? Yeah, so when I just go here, I can see all your diagrams. You don't have to just copy them in this PDF document. You don't have to. So just choose some of them, okay? It's up to you what to choose.
Okay. Let me see. So I was actually also gonna ask, like, what are you looking for the description for the software system? Is it like, okay, let me, it was in
The description
there.
of the software system. Uh, so here you can just, just expand what I asked you. This is split smart. Yeah, so this one is, you can just have a few paragraph. Don't focus on this one. Just focus on what I highlight. What I really want to see in this document is here. Is this.
Okay.
functional, non-functional requirements. So this is the only thing that's what I want to see. Like description, this one is like yeah, just summarize what I have here. Okay. Yeah, summarize is just give a summarize of this what this software does. But really what I want to see in this document is just a functional, non-functional.
Okay. Um, let me see. Sorry, I'm writing these down. Okay. Uh, so for the PowerPoint,
Hmm.
is it just gonna be the images straight up of the class sequence and state diagrams? Or
That's
should it
right. Just
have
class diagram, sequence diagram, and state diagram.
or should it
So
have like I was saying, should it also have like text or like descriptions
um
similarly to like the report file, or is it just only pictures and that's it?
okay. So yeah, please refer to my PowerPoint slides. You can see that I also have a class diagram in here, right? So in this class diagram, I list the flow of event. So the reason I want to put them in together in here is convenient for you to explain. Otherwise, you need to constantly go back and forth. You need to go to this class diagram. You need to go to the class diagram, and then you need to go to like the use case diagram. You go to the use case, and then you explain back and forth. So that's take time. So the reason I want you to copy this thing into the into the PowerPoint is for your convenient. When you do the presentation, you have only 15 to 20 minutes. It's better not for you to go here and check different diagrams to explain how you do it. It's better to consolidate them into a PowerPoint slides and show them and show the TA how you do it. Okay.
Okay. Let me see. So for the part where you said, I think you wrote 3 activity diagrams. Um, like we're actually like making 3 separate activity diagrams.
Yeah, three activity diagram. Yes.
Okay. All right. Yep. 3 diagrams. Okay.
Mhm.
So, um, for the diagrams, are we allowed to use extending stuff for it or no no extended things? Sorry. Like you remember from the use case where it had the extended ones? Are we allowed to
I
use those
understand.
or no?
For the use case, uh, I mean, in this case, since you have only 15 to 20, so you can see from here, the use case is to use to describe, to further, I mean, further clarify the system requirement item.
Uh,
So, if they are related, if some of them are related, you may, put them into like a relation. Otherwise, just put them like an individual. Like this add expense. Um, yeah, if you want to extend it, that's okay. For example, like add expense is a regular process. And if you have some exceptional use cases, uh, like uh, uh, like the timeout, like the negative expense or something like that, you can think of some exceptional case in addition to this regular add expense. That's also work. Okay.
so what I was
Yeah,
trying
so it's up to you. So it's up to you. So you can have some extended use case like a 1, 2, and 3 to so here you have to further clarify, to further extend this regular expense. That's also okay, but this one, it's like it's like the shortcut to my requirement. So my requirement, I extend to see like a 15 and 20 regular, I mean the regular use cases. And then if you put extended, then it's one add expense, then you can easily add more extended case, but this extended case is not as significant as the regular use cases, but it's still counted to like 15 to 20. Then, yeah, I won't deduct a point from you if you do that way, but if you do that, it may be difficult for you to draw the class diagram because you have too little use cases to use to draw the class diagram. So you know what I mean? So I do not recommend you have extended use cases in this case.
I meant basically for the okay, I was trying to say for the activity diagram itself. Are we allowed to use the extended parts in there or no? Like
Uh, I don't think the activity diagram has any extended. The extended the extended relationship only apply to use case, not apply to activity diagram.
cause I meant like cause the activity diagram is supposed to show like a scenario. And I was wondering if we're allowed to include like extended stuff for the scenario, or is it just like
The activity diagram is not necessarily tied to one specific scenario. It can go across different scenarios. So that's what so the activity diagram can come very complicated with the decision, with the concurrency. So this can go way beyond what one single scenario can do. Okay.
Mm,
Okay. Any more question from
wait,
students?
wait, I'm thinking, sorry. uh okay. So for the last part what you were saying was so basically so activity diagram is not including the extended stuff, right?
No,
So just
no, it's nice.
regular scenarios. Okay.
Mm-hmm.
Just regular scenarios. Okay. Um, so in the report itself, where you said where you paste the diagram in it, um, what sort of descriptions are you looking for? Is there like certain things that you're looking for in the descriptions, or you just kind of summarize it or something?
Yeah, just summarize something. Don't have to. I think that is a typo here. I said that you all use UML diagram because all UML diagram is already included in here. I don't have to duplicate it in the report. So here only a few that you believe that you add some explanation can help me to understand. Yeah, for example, like the state diagram, you can say that, okay, I have this state, and then how this state related to the attribute. Sometimes I mean this information is very helpful because that information is not included in the diagram itself. So do not copy all of the UML diagram, just copy just a few. For example, like a state diagram. I really want to see that like a state diagram. You can explain like what a state you are talking about in the diagram.
Okay. I was also wondering if we could have like possibly an extension for this lab for lab 8. And
Uh, the lab, remember, I'm not questioning about like how the quality, how you think of like a class diagram, what is class diagram is too trivial, it doesn't make sense. So I'm not judging this way. So I only judge that are you follow the regular process to come up with the class diagram. So for the sequence diagram, are actually each message here is matched with the method in the class. So I only check that. I'm not going to question like, oh, okay, this sequence diagram doesn't, I mean, the scenario this sequence diagram described doesn't make sense. I won't judge that. So there's no point to extend. You can just present, you can just submit whatever you have. and because you still have 2 weeks to refine it, and I know that you are going to do better in 2 weeks. So the lab A or 6, 7, 8 can be the preliminary work. You just submit the preliminary work, that's your starting point. And what I really want to see that you have a complete work and put everything in a closed loop, starting from class diagrams, the state and the sequence diagram is all explained together. That's you have 2 weeks to do that. So I'm not going to extend. So in short, I'm not going to extend the lab. That's the yeah. I hope you understand that.
Um, so basically that also goes for the future labs like lab 9 and 10. You won't
Yeah.
possibly extend them.
No, it's yeah. So yeah, because this is unfair. Because most of students complete on time, and I give the if I give some extension, then other student may complain on why you do that, you know. So it's better fair to be everybody. So as a future software engineer, you're going to face all kinds of deadline. You will see that in the industry environment, people don't tolerate extension. Yeah, so
Uh,
deadline is a deadline. If you miss it, you're going to face consequence. That's how the reality. That's how this industry work. So
uh,
yeah,
oh, sorry. I was saying in terms of the fairness thing, I was saying like if everybody could have the extension, because I feel like the stuff is more, it's like it feels more
this
heavy this time. That's all.
I've been teaching this course for many years. You know that in the past, the student I assign the lab the same day the lab due. Then student has only 1 hour and 45 minutes to complete everything, to complete the lab. And you are working on 2 days, and in the past, student has only 1 hour 45 minutes to finish it. And then I make the the criterion lower, and again, and now you have 2 days to complete. I know that if I allow you an extension, and there's some student will asking for more extension. So there's no limit. So it's better that we have a cutoff day. So today is only Monday. You have 2 days to complete, and I believe you can do it. So you can just at the beginning of the assignment and ask for extension, given you already have 2 days. So
Okay.
okay.
Well, I mean, I guess.
Yeah, so you can see that in the past, I mean, my requirement to the student was really, I mean, compare what we have today. And in the past, we don't have this recorded, I mean, the recorded lecture. Student has to come to the classroom and I show them what to do. If they miss, and there's no replay. Now is everything is recorded with a video. You can always come back to check the detail. Seems I mean the situation now is way better than before. So I hope you guys can do as good as your previous students. Okay.
Well, okay. I I
Okay.
guess I'll just do my best. And
Okay. Thank you. Yeah, and I appreciate
if
your
I have any
commitment.
more questions, I'll make sure to email you because I
Yep.
did email before about the whole extending for the labs, but there was
Yeah, so usually when
something
student ask for the extension, ask for these kind of things, yeah, because I already explained that in the lecture. I'm very unwilling to give extension. Yeah.
well, I mean,
Mm.
okay. Just yeah, basically it's because there was no response. That's why I was asking during the Zoom
Okay.
lecture.
Yeah.
Okay,
Yeah. Sorry about that.
that is
Okay.
all.
Charlie, see you unmute yourself. Any question?
Yeah, I only have two or three. Specifically for, all right, so the term project is basically a continuation for lab 6, 7, and 8.
That's right.
So specifically for the use case diagram and for the flow of event, I know you said you wanted a more refined version of it, like 15 to 20 use cases. Would it be possible if you were to, like, instead of not just refining, but redoing them,
Mm-hmm.
the flow of event as well as some of the use cases, so that you'll get a broader understanding and I'll be able to explain it well too. Because looking back at it, I kind of, rushed it. So that's basically my question. Is it okay if you could just redo some of the use cases and flow of
Yeah, of course. Yeah, I actually encourage the student. I mean, the refining process can go, can go on and on. The more you're understanding, the more you're working on a project. And when you look back, you find out your initial design, your initial use case, doesn't make much sense, or you
Mhm.
can do better, then you can always come back. And I
Awesome.
encourage the student doing that way. I want to see the differences. If you have your lab 6 is the first time when you have working on the use cases, and then your 10 project turn out to be completely different. That's something I want to see.
Okay. Okay. Thank you. And for the actual presentation of the project, is it a Zoom presentation, like a Zoom recording, or a Zoom session that we'll have to present to the TA, describing all the other stuff that you mentioned with the PowerPoint, showing them the UML modeling, all that other stuff?
Yeah, it's going to be the Zoom, and the TA is going to send out the instructions. So basically, I believe she's going to use the same Zoom she used for the lab. The same Zoom link, and then she will send out the Google Sheet for you to sign up for the time. So since we have like students, and then they may, you guys may join in different time of the Zoom to
Okay.
do the presentation, and then she will send the sign up so that you specify what time you can come, and then TA will be there to waiting for you on Zoom.
Okay, so it's in person. Is there like a time limit that we should have for each presentation?
Yeah,
Because I know you
15
said
to 15 to 20 minutes.
15 to 20 minutes.
Yeah,
Okay.
so that's each time slot. Each time slot is about 20 minutes, and that's what she prepared for.
Okay. 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 Cause the reason why I asked is because, um, possibly it might be, it might be lower, maybe 10 to 15 minutes, but if it's
Oh,
like,
that's okay. That's okay. As long as if you think you have 10 to 15 minutes, you can explain everything. So so what I see is how you actually get the class diagram from the use cases, and then how the sequence diagram connected with object, how to stay with, yeah, if you can explain this clearly in 10 minutes, yeah, that's fine. Yeah.
okay.
Okay.
Okay. Thank you.
Welcome. Okay, if there's no further question, I will see you next week, and have a good weekend. I'm sorry. Yeah. Have a good night.
Have a good evening.
Sorry. Thank you.
Okay, bye.
Bye bye.